In this lesson, we're gonna talk about on how to solve simultaneous equation by inverse of the matrix method. So here I'm going to show only you 5 steps to solve 3 by 3 matrix, which you can also use those 5 steps to solve 2 by 2 matrix. So you are given this is 3 by 3 matrix and this is 2 by 2 matrix. So you are going to find the value of, for A you are going to find the value of x, y and z, and for B you are going to find the value of x and y. So let's start by the solution of A. So this matrix is this matrix is going to be 2, 1, 3, and the coefficient of y is going to be 1, negative, positive 2, and the coefficient of z is going to be negative 3, 2, 2, and multiply by x, y, z, then which will be equal to 9, negative 2, and 8. So the first step to find you find the determinant of this equation. So to find the determinant, you will take 2, then you multiply by its matrix of minor. So matrix of minor, we say that we will ignore the rows and columns. So it will remain with negative 1, 2, 2, and 2. So we're going to find the determinant here. So it's going to be 2 times negative 1, which is negative 2, and 2 by 2, which is 4. So it will be going to be 4 minus negative 2, which is negative 6. Then using array sign, it will be negative 1 here. Because array sign will start with positive, negative, then positive. So here it will be positive 2, here it will be negative 1. Then also we ignore the rows and the column. So it's going to be 2 multiplied by 1, it's going to be 2. Then 3 multiplied by 2, it's going to be 6. So it's going to be 2 minus 6, which will be negative 4. Also it's going to be negative 3 multiplied by positive 3, it's going to be negative 3. So we ignore the row and the column. So it will be 2 multiplied by 1, which is 2. We subtract 3 multiplied by 1, which is negative 3. So it's going to be 2 minus 3, which will be positive. So it's going to be 2 plus 3, which will be 5. Here it will going to be negative 12 plus 5 minus 15, which is going to be negative 23 if you compute out. So the second step, we are going to find the matrix of minor. The matrix of minor, because we already find the matrix minor of the first row. So we're going to here we're going to only to start from the matrix of the second row. For one, it will be going to be, we're going to ignore the row and the column. So it's going to be 2 by 1, which will be 2, 2 by 3, which will be negative 3. So it's going to be negative 6. So it's going to be 2 minus 6, which will be positive 8. Also we're going to negative 1. So we're going to ignore rows and the column. So it will be 2 by 2, which is 4. We subtract 3 by negative 3, which is negative 9. So it's going to be 2 minus 9, which will be 2 multiplied by 2, we say it's 4. So it's going to be 4 minus 9, which will be 13. Also for A to 3, which is 2, we're going to ignore this and this one. So it's going to remain with the 2, 1, 1, negative 1. So it's going to be 2 minus multiplied by negative 1, which is negative 2. We subtract 1 by 1, which will be 1. So it's going to be negative 2 minus 1, which will be positive 1. Also we're going to the third row. We ignore the row and the column. So it's going to multiply this one and this one. We subtract this multiplied by this one, which will be negative 1. Also for 2, we ignore the row and the column. So it will be 2 by 2, which is 4. We subtract 1 by negative 3. So it's going to be 4 minus 3, which is 7. And the third one, we will ignore the row and the column, which will be 2, negative 1, 1 and 1. So it's going to be negative 2, subtract 1, which will be negative 3. So to find minor of matrix, in the Roman 1, first step, we already have the negative 6, negative 4, and 5. So it will be for second row, it's going to be 8, 13, and 1. And for the last row, it's going to be negative 1, 7, and negative 3. Deal with the minor of the matrix. Then from there, after finding the minor of the matrix, we're going to find the matrix cofactor. The matrix cofactor, we said in the previous, on the basic of the matrix, we are going to multiply the array sign multiplied by the minor of the matrix. So the array sign for here is going to be positive, negative, positive, negative, positive, negative, positive, negative, positive. We're going to multiply by matrix of the minor, which will be negative 6, 8, 1, negative 1, negative 4, 13, 7, 5, 1, and negative 3, which will be the same as if you multiply this one, it will be negative 6, multiply negative by negative 4, it will be positive 4, multiply positive plus 5, it will be positive 5, negative multiplied by 8 will be negative 8, 13 multiplied by positive, it will be 13, negative multiplied by 1 is going to be negative 1, positive multiplied by negative 1 will be negative 1, 7 multiplied by negative 1 will be negative 7, positive multiplied by negative 3 will be negative 3. This will be the matrix cofactor. After finding the matrix cofactor, the next step we are going to find the adjournment or transpose of this matrix. So the transpose of this matrix, we are going to change the row into column. So for your example, it's negative 7, 4, and 5. So if you change from the row to column, it will going to be negative 6, 4, and 5. Also, you go to the second row, it's negative 8, 13, and 1. So if you change it into column form, it will be negative 8, 13, and negative 1. Also, the last row, it will be negative 7, negative 1, negative 7, and negative 3. This will be the adjournment. After finding the adjournment, the last step, we are going to find the inverse of this matrix. The inverse of this matrix, we always will take 1 over. You remember the determinant, we found it was negative 23. So it's going to be 1 over negative 23. You're going to multiply by this adjournment. After multiplying the adjournment, therefore, from here you are going to know how to find the value of x, y, and z, which will be the same as this inverse of the matrix multiplied by its function, which were 2, 9, negative 2, and 8. So it's going to be for x, it's going to be 9 by negative 6, which will be negative 54. You add negative 2 multiplied by negative 8, which will be positive 16, minus negative 1 multiplied by this one, which will be negative 8. Then you multiply by 1 over negative 23. If you compute here out, it will give you 2. So also we go to find the value of y, which will be negative 1 over 23. You open the bracket, so it's going to be 4 by 9, which is 36, 13 by negative 2, which is negative 26, and negative 7 by 8, which is negative 56. If you compute here out, it's going to give you 2. And for the z, it will be negative 1 over 23. Then here we'll go multiplying by 5 by 9, then negative 1 by negative 2, and negative 3 by negative 8, which will be negative 24. So if you convert it into the bracket and multiply by negative 1 over 23, it's going to give you negative 1. And this will be the value of x, y, and z for 3 by 3 matrix. So let's go on how to find the value of x and y for 2 by 2 matrix using inverse method. So first we say that we find the determinant. So determinant here it's going to be 2 by 1, which is 2. We subtract 3 by negative 3, which is be negative 9. So it's going to be 2 plus 9, which is 11. After finding the determinant, we're going to find the matrix of minor. Matrix of minor, we're going to ignore the row and column. For 2, we're going to ignore the row and column, which will be 1. For negative 3, we're going to ignore row and column, which will be remain with the 3. And for 3, we're going to ignore this one and this one, will remain with the negative 3. And for 1, we're going to ignore this one and this one, so it will remain with 2. This is the matrix of minor. After finding the matrix of minor, the third step, we're going to find the matrix of cofactor, which will be multiplying the array sign by matrix of minor, which will be positive multiplied by 1 will be 1, negative multiplied by 3 will be negative 3, negative multiplied by negative 3 will be positive 3, and positive multiplied by 2 will be positive 2. After finding the matrix of cofactor, next we're going to find the adjournment of the fourth step, which will be changing row into column. So it should be common 1 negative 3 will be changed to 1 negative 3, and 3 2 will be start with the 3 and 2. After finding the adjournment, the last step, the fifth step, we are going to find the inverse of this matrix. So it's going to be a negative of the matrix is going, a raised to negative of the matrix is going to be equal to 1 over. You remember that the and time management we get it was 11. So it's going to be 1 over 11. We're going to multiply by the matrix of 1, 3, negative 3, 2, which was the adjoining. So to find the value of x and y, we're going to find the multiply inverse of the matrix multiplied by its function, which were 1 and 7. So it's going to be like this. So from here, to find the value of x, it's going to be multiplied by 1 multiplied by 1 is 1 over 11 plus 3 multiplied by 7 is going to be 3 multiplied by 7 is going to give you 21. So it will be 21 over 11. So if you compute here out, it's going to give you 22 over 11, which will be the same as 2, which will be the value of x. For the value of y, it's going to be negative 3 multiplied by 1, it will be negative 3. So it will be negative 3 over 11 plus 7 multiplied by 2, which will be 14 over 11. So here it's going to give you 11 over 11, which is the same as 1. Thank you for watching my video. On the next step, we are going to show you how to find the value using Cramer's rule. Bye bye.